Okay. Hello, science family. I am so excited for the project we are doing today. It is by far one of my favorite chemistry projects to do with kids. If you are on YouTube, you can chat, you can type in if you want a little hello from me in the shout outs once I get there. And make sure that you subscribe, you like, you give us a thumbs up so that we can keep spreading our science message around. And while we wait for the shout outs to come in, I want to give you an idea of what you'll need today. So you want your purple cabbage juice, which you have boiled and strained. So I just put it into a nice big thing. Here, you'll need some like little cups, bowls, whatever you want as your mixing thing. If you have access to a kitchen sink or a sink of some sort, that's going to be great because you can use less stuff. Kids can go wash their stuff out as they go. You're going to want something to color with. So pencils, crayons, markers, pens, whatever works for you. You want something that has different colors. And you'll probably want one of our lab printout books. So if you're a patron, you can get this. It would have been sent to your email as an easy download to print out. And to give you an idea of the colors you want, this down here is going to be the colors that we'll be looking at. So you want to make sure you have colors for that because we'll record things by coloring in. And then the last thing you'll need is all of the crazy stuff. So I've got stuff that is like, I've got the normal like salt and baking soda and all that jazz. But then I have stuff from under our sink, stuff I haven't seen forever, like spray starch. I don't even know why I have that or what it's used for. Probably a science experiment in the past. I've got like weird things, like our school had like a crazy lice outbreak. So we just bought all of these like specialty shampoos. And I'm like, I wonder if that'll be interesting. I've got Lysol wipes to see if that'll be interesting, like whatever you want. I have vitamins in here. I've got spices in here. So just get a whole big set of like whatever you want to test and see what happens with today's stuff. And we'll be talking about acids and bases. So make sure you stay tuned. Do we have anybody that's watching that wants a little hello?
We have George and Henry.
Hello, George and Henry. Again, I love that you guys are here every single day. It's awesome.
We have the Hertz came back, Taylor and Jacob and Megan from Virginia.
Hello, good morning. Oh, I am not in Virginia. It's like afternoon now. Good afternoon, Taylor and Jacob and Megan.
And we have Clara and Anna.
Hello, Clara and Anna. It's nice to see you ladies today.
And Chloe and Amelia and Calvin.
Hello, Chloe and Amelia and Calvin. You're back. I like it.
And Raiden's back.
Raiden's back. Yes. You're going to love this one, Raiden. It's going to be a lot of fun.
And Emma and Lydia are here.
Oh, Emma and Lydia! Yay! I'm so glad you guys are joining us today.
And Kavi's here.
Hello, Kavi! Maybe your brother. I don't know. But if it's just you, that's just as awesome.
And then we got the good kids, Sam and Ellie and John. They had all the, didn't they have all the bags?
Ooh, is that the good kids, Sam and Ellie and John? You guys did the awesome black bag idea. This was our project from yesterday. And this might be the group that you guys decided to do black. And I'm super curious how that experiment comes out in the end. Good afternoon or welcome.
And we have Kaya. I think they're from Pennsylvania.
Hello, Kaya.
And Manas is here.
And Manas. Awesome. We have lots of friends.
All right. That's all the call-outs we have right
All right. So today we are going to talk about acids and bases. And we've actually done a lot with acids and bases already. So when we did the osmosis experiment and we set it up and we put an egg in vinegar and we let it sit for days, we actually were letting that acid eat away at the eggshell and it was making some gases. Ruby actually noticed that there was bubbles on our egg and it was making gases and it was making water at the same time. So we did acids then to eat away our eggshell. We've done acids in our copper nails experiment when we took copper pennies and we took the copper off of the pennies. We used an acid to break that copper off of the pennies. So we've done a lot with acids and bases, but we haven't actually talked about what acids and bases are. And they are super important. I mean, we use acids and bases all of the time. So like your stomach uses super strong stomach acid to break down the food that you eat. If we didn't have stomach acid, like we would just have pretty much chewing and then like we wouldn't get all the nutrients out of our food and we would probably starve. It would be terrible. So stomach acid really helps us break down food and get more out of each bite of food. We have acids in our cars. Car batteries rely on acid to create a battery so that you can start the car. which is amazing. We rely on acids a lot right now because when you're cleaning your house, a lot of times we use vinegar, which is an acid, or bleach, which is a base. So there's all of these things that we use acids and bases in everyday life. They're super useful, but what in the world are they? Well, they are really tiny. Acids are any solution that has a whole bunch of teeny tiny hydrogen pluses floating around. The more the merrier, the more it has, the more acidic it is. And its opposite, the base, has a whole bunch of, these are called hydroxide, they're OHs floating around. So you'll notice acids have extra positives floating around, bases have extra negatives floating around. And if we put them together, if we take an acid and a base together, like if we took vinegar and a baking soda and put them together, often we'll have a chemical reaction. It usually makes a gas and something else. And if we count up, because remember positive and negatives, they love each other. So when these guys see each other, when acids and bases cling together, we make a new chemical compound. It has two H's, one O. Oh wait, I'm doing this the wrong way. We'll do it this way. Two H's, one O. Think in your head, have I heard of that? Two H's, one O. H2O. I don't know, is that a useful thing? Do I have that in my life? Can you think of what H2O is? It's super helpful. It's maybe the most dominant thing on Earth. It's like most of our body is made up of this. If you've thought it in your head, you can check it now. These together, when we have the positive of the acid H and the negative of the hydroxide ion, they come together, they make water. What makes something more acidic? Well, it has more hydrogen ions, but if I'm talking to somebody, do I just say it's like super duper acidic versus super acidic? And that's not like, what would be difference between super duper and super? I don't know. It's kind of hard. So what scientists have done is we've made a scale. And so acids are, they've given a scale, and it's like based on how many of these guys are in your solution. And it can be like from 0 to 7. Water 7 because it's neutral. So 7 is sort of like our midpoint. And if it's got more and more of these, we get more and more acidic. So we get to 0. If we have more and more of these, we get more basic, and we go all the way up to 14, which is perfect because 7 was at neutral. It's our midpoint. So that's how we look at acids and bases, but you can't tell by looking at it. And maybe you want something specific. In baking, we like to mix acids and bases together because when we do that, things foam up, just like vinegar and baking soda foam up. And so we might need to know, what do I need to add an acid? And you might be able to think about things because acids usually taste really sour or tart. So like lemons are probably acidic, but somebody should check this for me. And bases usually taste really like bitter or soapy. So soap might be basic. And we can check that today too. And you might be wondering, well, how do I check it? Because I can't look at some solution or anything and be like, where are those little H pluses? Is that so small I can't read her handwriting, or are they just not in there? Kind of tricky because hydrogens and hydroxide ions, they are so small. We can't actually see them with our eyeballs. Like no chance. So how do we see them? Well, we use something called a pH indicator. So the pH scale was at 0 to 14. So 0 to 7 was something that was acidic, and 7 to 14 was something that was basic. So we need something that will show us what it is. And the things that we have learned to show us are different chemicals that change with acids and bases. And we are going to use purple cabbage today as our pH indicator. It's going to indicate, it's going to tell us, not through a little voice. I don't think I can hear it. No, doesn't talk to me. But it's going to somehow communicate to me whether it's an acid or a base. And the way it's going to do it is a compound called anthocyanin that's in there. And in your lab book, you actually have this great little spot the changes worksheet. And this is the same compound inside of our purple cabbage. It's called anthocyanin. And as we add maybe more hydrogen ions, those positive ones to make it more acidic, I change what the bonds look like. So I change if there's double bonds, I change if there's free electrons, I change all of these things, which then changes the color of the molecule. And you can think about this in sound, like if I take a short metal piece and I ding it, it makes a different sound if I take a long metal piece and I ding it. Those are different sounds. So I could like actually maybe kind of figure out, ooh, how long is a metal piece based on the sound? And in fact, here I can do the same thing. I can say, ooh, what does the chemical structure of anthocyanin look like based on its color? Because the colors change the way that light interacts with this molecule. So by adding those negative charges, I can change it one direction. By adding those positive charges, I could change it in the other direction. And that will let me see if something's an acid or a base. Because here I have actually 3 liquids. One is an acid, one is a base, and one is neutral. And in fact, they all look clear. So I cannot determine if something's an acid or a base by looking at it and saying, ooh, everything that's orange, totally an acid. Or ooh, everything that's clear, totally a base. Now you might be like, Dr. Erica, not so sure. Those are all clear. How do we even know there's something different about them? And now is where I'm going to use in the beautiful purple cabbage indicator. So when you're doing this project, and we're going to meet over in Zoom, and we can test all these different things together. My girls will come test. They've been begging to do this. They're so excited. So what you'll do is you'll take a little bit of your purple cabbage, and you can pour in some of whatever liquid you're curious about. So whatever liquid or powder you want to know, is this an acid or a base? And we'll pour it in, and hopefully this will somehow tell me something. Let's find out. It's not going to talk to me, but hopefully I'll be able to see what's going to happen. Ooh, yes. Look at this. It's pink. So it used to be purplish blue, and I poured something in and it's pink, which means I did something. Now I'm like, did I add extra hydrogen ions to make it more acidic? Or did I add extra hydroxide ions to make it more basic? Well, the thing is we use scientists to know that. And I have actually a pH scale on here for you. And it will tell you based on color. This is not yellow, so it's not basic. It's not green, so it's not basic. It's not bright blue, so it's still not basic. It's not that purplish blue I had, so it's not neutral. Ooh, but it is pink now. It is pink, which is kind of like a 4, maybe between a 4 and a 2, we could decide. That means it's acidic. So whatever I added here was acidic. Ooh. Interesting. I wonder what that could be. A clear liquid that's acidic. And I could add another one and I could see, is this going to do anything? Oh, I don't know. That doesn't seem like it did much. We can now compare the two, but this one's seeming pretty the same. And if I look on my scale again, I can compare this color. And I'd say, oh, yep, that's pretty neutral. So whatever I added here, whatever clear liquid that was, is probably neutral. And I could add a different clear liquid, just so we know that clear liquids could be acids or bases or neutral. Well, we've seen the acid. We've seen the base or the neutral. So what do you think this one is? Think in your head. The third one, we have acids, bases, and neutrals. So we can add this one in. And ooh, look at that. It turned yellow. Well, we can take our handy dandy pH little scale and I can hold it up to it. And I can go back and I can tell you guys what these are because I had 3 liquids in there. One was water, one was vinegar, and one was bleach. So think in your head, was water neutral or not neutral? Water is sort of when all of these guys mix together, which means water is when it's neutral. So this guy, I had added water to. Good to know because this one is safe to be around. I now have vinegar or bleach left over. And the question is, which one is which? Well, if you did the project with us with the copper nails or with the egg, you'll know we added acetic acid, which sounds fancy, but it's actually just plain old vinegar. And if I look on the scale, I can see that the one I either have yellow, which is basic, or a pinkish, which is acidic. So the pink one is the one that I added vinegar to. And that means that this is the one that I added bleach to. So this is a way that we can use to get information about something we can't see in our liquid. Now, this one, which is acidic, because I know because it's pink, has a bunch of extra hydrogen ions in it. Where's my little H? It's got a bunch of extra ones of these. We got so many extras of these. What I could do now, if I wanted to, if you're at home and you're like, I wonder, we could try to bring it back to neutral. So I would have to bring it back to neutral, I have to add some hydroxides. I have to add some of these guys so I can bring it back to neutral. And if you know of a basic thing that's around your house, you could try. I know that baking soda is actually basic. So what I could try to do, I'll put some on the table. I could sprinkle some in and I could make it fizz and I could let this reaction go and we could see if I can bring it back to neutral. Ooh, it might take more than I thought. I thought it would just take a little bit. Bonus, you get to see the fizzing, which is amazing. All right, let's add a little bit more. The trick is to try not to overshoot it. Because if I go too much, then I'll have a basic solution. Ooh, but also now we're about to explode. It's about to happen. Ah, that's okay. Let's see, are we turning more purple? I noticed the foam is actually more purple. But we might lose all of our sample because I didn't do it in a big enough cup. I'm not sure. Maybe I need a base that doesn't fizz with my acid. But that's okay. We're gonna add some more now. Ooh, thank you. Thank you. Put that down right there. All right. Ooh, it's coming back. It's getting darker. Let's see. Let's keep adding. You'll notice my bubbles are getting more and more of the purple, and I'm bringing it back. See how now it's more purple than it is pink? So I'm bringing it back by adding the base. I can make some water and I can pull those excess hydrogen ions out and remove some of the acid and turn it into neutral. And if I wanted to, I could keep adding more base and I could go the other direction. And the same thing is here. For the base, I have too much hydroxide ions. I have too many negative charges in there. And I could take vinegar, which is an acid, and I could try to bring it back to an equilibrium. So I could take the excess hydrogen ions in here and react it with those excess negative ions in there and try to bring it back to where there's not excess of anything. This is going to be trickier though because bleach is a very strong base and the vinegar is not. So we can see what happens as we go though. Let's check it out. I'm not sure if I'll make the color change because I added a lot of bleach. Yeah. It's not going to change. But if you only added a little bit of bleach, you might be able to, or if you had a stronger acid than vinegar, you would be able to bring it back. Safety. In terms of safety, that's very important. Nobody is going to eat lunch at this time or snack. Nobody's going to drink anything right now when we do this in Zoom. We're not eating or drinking anything, even if the stuff we work with is edible. And that's just basic lab safety. When you're in a lab, you never eat anything. You're not even allowed to eat in a lab. Like when I worked in the lab, it was like, you have to like take off your gloves, which is a great indicator. If you're wearing gloves, you should not be eating anything. Take off your gloves, you gotta take off your lab coat, you gotta leave, you gotta go wash your hands, and then you sit in a spot that's okay to eat. And because we're doing kitchen science, it can be tricky. Like, ooh, I normally eat in my kitchen, which is true. But we wanna make sure that we're not going to eat anything. And we're not going to drink anything, okay? With bleach, kids should probably not be doing bleach unless you trust them like massively, but I don't even trust my children with bleach. I will pour the bleach in for them if they would like to. And we are also doing like other various materials. So make sure whatever materials we have out, you're comfortable with your kids doing. And then kids know we're not eating or drinking. And we wanna make sure that we are being thoughtful about what chemicals we're going to be allowed to use. So your moms and dads get to choose, and you don't get to be mad at them.
Nothing from the garden, from the greenhouse, or from the shed. Those are too strong.
Things from the greenhouse and the shed are probably too strong, but I did use bleach. You can do drain cleaner. They will come out at different colors, which is really cool. And you'll notice even like this one I knew was just purple cabbage and vinegar and baking soda, so I put my finger in it. That's probably not the best safety idea, to be honest. It's because I didn't have a spoon. But if you're going to mix stuff, like I would not put my finger in that one because that one is bleach and that's a terrible life choice. So just be thoughtful about it and test some things because there might be some things that surprise you this is one thing I really want to do real fast, real quick, because there is some things that you might think, oh, maybe I didn't put it on the table. Okay, here's a trick then. Here's something you guys are going to test for me. I want to know what happens when you put salt. If salt changes the acidity of our solution. Now remember, to change the acidity, we either need to somehow add hydrogen ions, H pluses, or hydroxide ions, OH minuses. We have to add one of these two. And salt is sodium chloride. So I want you to think about that when you test it with salt. All right. So we are going to head over into our Zoom classroom so we can do this all together and have lots of fun. And we'll have, well, we won't have lunch today with you guys because we're not going to eat while we're doing this project. But we'll have lots of fun until it's time to sign off. Make sure that if you haven't joined us on Patreon yet, you come on over and you join us for our 6 weeks of science. We're live every day with a new science project. It's going to be so much fun. And don't forget to make sure that you share it with all of your friends and tell everybody what we're doing. And then share out our social media and all that jazz. So we will see you guys in Zoom right now. And then those of you on YouTube, we'll see you guys tomorrow as we engineer greenhouses. Have a great one.
I'm moving the chair over there.
Belly claimed this spot, but you can have this spot.